Awesome. Well, thanks everyone for tuning in. As mentioned, definitely talking about Terraform enablement and structure and not boundary. Maybe next year we can cover off boundary from my perspective, but not today. So I'm assuming everyone here kind of knows about Terraform and is, really familiar with how it works and kind of why we use it. But I think that there's a much deeper understanding we can get about the problems that we're trying to solve. And a lot of the issues that I see day to day with people using Terraform stems from not understanding the scope in which we can solve some problems, but also like how we can actually structure to solve some of those problems earlier as opposed to later. So we'll get straight into it. So I got Terraform, now what? So I can write output hello world, and we're at HashiTalk, so we can get started with that straight away. But what are we actually solving with Terraform? Okay, we can provision infrastructure, we can write hello world, we can do lots of really cool things, but what are the actual dimensions at which we're trying to get value out of leveraging the platform itself? And so my name is Lachlan White, as Melissa said. I'm super pumped to be here. I'm a general manager of technology at Lab3, who's a HashiCorp partner as well as a Microsoft partner. And then also in my spare time, super happy to be involved with the community of HashiCorp and the community ambassador for HashiCorp, and actually run the Melbourne HashiCorp user group. So if anyone's looking for a place to talk about any of the products, just hit me up. I'd love to have you come and speak at the user group. So we'll get straight into the problems we're solving. So what are we actually solving with Terraform? So we know that it builds infrastructure, but what are we solving? We're really solving two different types of complexity, which is really well documented on the HashiCorp website. So we're really looking at technical complexity. So how we're solving different platforms with different interfaces, and that could be different clouds, GitHub, GitLab, different platforms that are using different ways of working and interaction. And Terraform achieves this by creating a layer of abstraction based around the workflow of products, as opposed to the resource level specific actions and abstraction. And so what we mean is that a VM, it's cool to abstract away how to build a VM. We can do that in something like Bash or PowerShell, but actually the entire workflow and the way of working is unique to how Terraform operates. And so that gives us a really unique view in terms of how we can solve some really, really big problems in terms of organizational complexity, which is the lesser spoken about kind of issue that we address with Terraform, I find most of the time. And so that really stems from, as infrastructure scales and we're required to get more people to support that infrastructure we're scaling, how do we do a couple of things? How do we delegate the ownership of infrastructure across multiple teams and empower them to work in parallel, which is without conflict, which is the important part there? How do we make sure that people are operating with a healthy friction, but not blowing that out of the water and causing issues and delivery slowdown when we were trying to do the opposite, in fact, speed it up? And I think this last point here, whilst acknowledging the uniqueness of ownership and responsibility across the different domains, is really important. And I've often really struggled to visualize or explain how that looks and feels in terms of what do you mean by organizational complexity? Surely it's just infrastructure. We're just building virtual machines and applications. Surely there's not that much to it. It's just, I need one of these and one of these. Well, what I did was I threw together an actual image that I helped to explain this. And I've done it in a talk before, so I won't spend super amounts of time on it. But essentially what we have here is created this visual to show how there's a change in organizational responsibility and team culture and interaction as we go through what would be a standard digital transformation or cloud journey, right? And so when we're on the left-hand side and we're in that traditional IT operating environment, we've got application teams, data teams, middleware teams, network teams, server teams, and everyone's really familiar with who and which team does what action. We've got Joanna from the server team if I need a new VM. I've got John from networks, Mohammed from data, he can build me a new pipeline. So I know exactly who to go to. As we move into the hybrid IT world, that starts to get a bit more confusing, and all of a sudden, the colors that we have start to blend and change. And we've got these new teams coming into doing things that our team used to look after. So now the app team's kind of reaching into the data space because they think they can add more value through representing data in a different way. We have this DevOps team that's kind of come in because we were doing a digital transformation and they're trying to take over almost everything that's there, or have a hand in every pie where they can to try to help out. But what this actually does is it creates a lot of tension and conflict and in a not healthy way. And so what we end up doing is blurring the colors and responsibilities and causing teams to actually try to hold on to what they have as tightly as possible, rather than opening up and collaborating with us on what we're trying to do. And the worst part of all that is that in an actual corporate environment, that actually looks like it's being extremely successful. We've gone from a traditional environment where to provision a server was 6 weeks to get hardware provisioned. And now we're in a hybrid world in cloud where we can build it in hours or minutes even. But what it looks like on the outside is maybe we've only gotten a 3-week benefit because of this conflict we have between the teams, and we've thrown away 3 weeks of benefit we could be getting. And so that's where we're starting to see a lot of reward coming from people pursuing this cloud native based option, where I think Terraform fits in perfectly, where we still have all the different layers and unique responsibilities across those different towers. But we're trying to operate through a single way of working, where we use code as the source of truth, or GitOps in this case. And what we're trying to do is empower people from security, networking, platform data, app devs, infrastructure engineers to all operate on a platform in a single way, okay? And that's a really powerful thing that we can do. And so once we do that, we start to see all of those blockers and areas of concern fall away, and we can actually start to solve those technical problems that we really wanted to start with in the first place. So we got Terraform, and what we're trying to do is use all of these benefits we have across the different domains to extract those benefits. So with infrastructure as code, we can increase our speed, we can get reusability, as we talk about with modules in a little bit. It's highly human readable, which means we can get started really quickly. That single way of working, and we can use it for a declarative implementation, and Git being the source of truth gives us a lot of benefits there too. It's modular, we can have building blocks, standardize those, empower developers, and it's extendable. And we can, and that's really important. I mean, I think I made this slide a couple of days ago, but I think we've passed 800 providers now, and probably well and truly over 5,000 modules on the Terraform registry. So that growth over a short amount of time is absolutely crazy. So where does Terraform fit into how we want to solve those problems? So it's really well put on the documentation as well, that Terraform's purpose is to provide one workflow to provision any infrastructure. And to me, infrastructure doesn't just mean servers, it means all of those different components on those different platforms. So, cloud, Kubernetes, etc., but also GitHub repos, Grafana connectors, Splunk dashboards, all of those things we can extend to and make everyone work in a single way of working. And we can do that through building things ourselves or leveraging community and the public module registry that we spoke about before as well, which is a really cool happy medium between, we don't have to reinvent the wheel to get benefits quickly. We can leverage the community to accelerate the delivery of what we're doing, which is really, really cool. So where are you at in your journey of fixing these two problems? And again, HashiCorp defined this really well and call out 4 specific stages of maturity that I think describes what I see, day to day with people using Terraform effectively, really, really well. We've got a manual stage where people aren't using infrastructure as code. They're using combinations of bash scripts in the browser. There's not really any standards, but specifically there's no naming standards. It's kind of a free for all. And then there's no traceability because we don't know where things are being done or actioned. So it makes it really hard to find out who was responsible for what or who did what changes. We have semi-automated where there's a combination of the UI and the CLI and limited traceability because we've got that combination, and rollbacks are hard because we don't know who's done what where. So even though we are starting to use CLI more than we are a user interface, it's really hard to find out what was done where. And then we get to start into where I see most people, which is within that infrastructure as code space. So we're leveraging Terraform open source. We've got provisioning and deployment automated most of the way. We've started to use a GitHub or a VCS provider to store our source files. And we've even started to look at Terraform modules and how those modules could be used in partnership with architectural patterns and how those work together to enable people to accelerate their infrastructure faster without having to get approval every time. And then my favorite and most preferred way of working is actually through the collaborative infrastructure as code space, where we start to leverage tools such as Terraform Cloud, Terraform Cloud for Business, and Terraform Enterprise, and we unlock huge amounts of capability around self-service infrastructure. We unlock these concepts of consumers and standardizers, where we've got consumers who are simply just looking to achieve and build something, and we've got these standardizers who are actually working with the architects, or maybe they're even architects themselves, building the standards in which people can consume across the organization. We get to leverage workspaces in a much bigger way than what we can locally by using Terraform Cloud or TFCB, where we can have RBAC controls and state level specific controls on those workspaces to see who can access what information or who can trigger what builds and runs. And then what's really cool about those offerings is we get the remote module repository. So we're able to create our modules ourselves or bring modules from the community in and publish them out into our organization or to our teams that we're working with from our own controlled space, as opposed to being public, which is a great asset to have within your platform that you're building. So it's all good to talk about all those stages, but what does that actually look like in terms of the structure of each of those different steps, and how do they actually, those levels of maturity, relate to different patterns we've seen that have surfaced from the community as well? And so one of the favorite talks I've ever seen about Terraform was done by Nikki Watt in 2017, Hashi Days in London, I believe it was. And she coined these three terms, which we'll cover all of those today, and then one more that I'm seeing happen and I've created a name for that I think would be really interesting to talk about. But the first one that Nikki covered off was this concept of a Teralith, which is a cross between Terraform, obviously, and a monolith, where we have lots of code deeply coupled and strung together. And still to this day, this is kind of the most common implementation that I see, where people are essentially having a single file in a repo that contains all of the config across the board. It's okay to get started, but typically what happens is we end up in this situation by having a POC with Terraform and then seeing how easy it is and wanting to run really fast without understanding how we could set it up potentially in a better way. And so what happens is we end up with a couple of pros and cons to this approach. One of the pros is obviously we get infrastructure as code, which is totally awesome. It's exactly what we want to be doing. However, what we do is we get a lot of these concerning cons where we have multiple environments in a single file. And we can see that by having the name of our first app service there being test Teralith here. We've got a test environment declared up here, or test app service, I should say, with a dev app service as well. And they're very close together and they're both hard coded, which means that to get any changes in here, we have to literally go in and change those hard coded values ourselves rather than using variables or surfacing them in a different way. We get a high amount of duplication across this because we have to replicate those resources every time. And each time we do that, there's a chance we do something wrong when we're duplicating. So it opens us up to a lot of risk. Which we obviously want to avoid. So when it's deployed, it kind of looks like this, pretty simple. There's a single Terraform blob that's managing the different resource groups in Azure and environments, prod, test, and dev, and they've all got these app service and application service plans in there. And that can be great as we're getting started, but as we want to uplift the capability that we have, we've kind of only reached that semi-automated-ish state. We're not really there, but we've kind of had an experience and we now know where we want to go. And we want to start getting a lot more of the reusability out of the platform that we're looking for. So that leads us into TerraMod, which is the next level that Nikki spoke about as a pattern. And so what we have here is we've reached the status of infrastructure as code on our journey. So instead, we didn't do manual, we moved into semi-automated, and now we're at infrastructure as code. And what we can see here is straight away, there's much more of a structure to the way in which we're operating. We've got an environments folder, and within that, actually, we've got the different environments that we're deploying into, being it dev, prod, and staging. And we also have specific declared files for main variables and versions to monitor and manage what we're doing within those environments, which is a huge key. And TerraMod comes from the word Terraform and module, and we have local modules here, as you can see at the bottom of that directory structure. So within here, we have an app service one, virtual network one, maybe a couple other things, and also a README to explain what we're trying to do with this repository. But what's great here is that we've simplified how we're implementing these resources. And this could be 100 resources, or it could be one, like it is in our case. But what we're able to do, as you can see from the source link in the middle of the code editor there, we're able to link directly to this module and pass in only the required values that it takes to build that. So what we can do with that is start to standardize some of the implementation that we're doing to the rest of the environments, and maybe with other team members that are using that repository. But again, we run into a couple of problems. We've now got separate environment DIRs and files, which is fantastic. We've got local modules giving us some of that reusability. It's definitely drier. We definitely have a lot more reusability and not as much duplication, which is great. But our state's still local. It's still, I ran this on my machine and I executed on my machine, and potentially that means the state's on my machine. We can look to leverage, obviously, Amazon S3 backends and Azure Storage Account backends, and et cetera. But most of the time when I see this being used, they haven't reached that level of maturity yet. And so what that means is that we can't then scale that across the organization in an easy way. Even if we are using those other backends, it's still more complicated to manage. And so we've really enabled a specific team and use case to solve that problem, as opposed to solving that for the organization, which is what we're trying to do. And so when we deploy that, this is kind of what it would look like hypothetically, right? We've got our prod, our test, and our dev, our different environments now colored differently with different state files, which is great. And we've got that local modules instance where we're able to now share that across those different environments, which is fantastic. So we've got that separation that we wanted and some of that reusability, but now we need to look at how can we take that to the next level? How can we structure our repository, reuse as much as possible across an entire enterprise? And that's where Nikki really hit the nail on the head for me with this Terra service concept, really where we start to see the benefits of using a collaborative infrastructure as code model, right? And so we can see on the left, we still have a pretty similar directory structure for this directory structure for our infrastructure as code. We have our environment still, dev, prod, staging. We still have the same files. We start to see some people using examples. So creating an example of how to use what's available within this repository to deploy into different environments, which is a great practice to get into. And of course, a README, which is super important. But the biggest changes we'll see is that there's another block of code, another stanza at the top here for Terraform, where we're configuring a remote backend specifically for the HashiCorp 21 organization. And we've created a workspace called App One Development, which is great. And so that's where the remote state of our code is going to live. And we can start, because of that remote state, enabling other people to work against that workspace and against this code base to collaborate on the infrastructure we're building together, which is really cool. So we get that collaborative infrastructure as code experience that we've been looking for. We also get the ability to leverage that private module registry I spoke about before. So within the app service module, our source is no longer a directory within our repository. It's actually directly from my HashiCorp 21 organization. Again, and now I can version specifically with an actual declarative state the version of that module that I want to run. And you can do that within other versions using direct Git tags, but it's very clean and crisp here that makes it easy for people that are new to Terraform to use. And again, we're only passing the variables that we want to use within there. And so we start to really see how we can collaborate against this with multiple people, and start to then also use some of the other benefits we get from the paid for Terraform services, like cost estimation. What will this change my infrastructure actually cost me? Sentinel policies, writing policies to govern security controls around what's happening, or maybe whitelisting specific modules for specific workspaces and whether they can or can't be used. We get a lot more of a maintainable platform across how we're implementing this, and it's strongly declarative. So you still see that in every environment we have a main that says this is exactly what's going to be deployed into this environment, which is a really strong benefit to have, especially from an audit point of view. There is additional complexity in the setup, though. We need to agree on what's the structure going to be, what's the default for READMEs. Do we have a branching strategy that we want to apply to this repository as well? How do we manage all of those things and the access that's needed into Terraform Enterprise or TFC, right? But the benefits far outweigh the complexity that we get. So that looks a little something like this, where we now have a remote module, and now instead of environments, we actually have different apps altogether sharing that same architectural pattern. And so now app 1 has a dev, test, and prod, app 2 has a dev, test, and prod, and so does app 3. And those, when they're run and built, are now stored in the remote state within our Terraform Cloud or Terraform Enterprise or Terraform Cloud for Business instance. So that is that introduction of that new layer at the top that gives us that ability to really benefit from that collaborative infrastructure as code experience. But what I've started to see recently when talking to people is that kind of declarative state, after people get used to how it works, they're looking for a way in which they can become less, write less code. They want less duplication in their Terraform code, and they want to reuse as much as possible and drive as much through variables as possible. And so what I've started to play with the concept of is this idea of Teraless, which is a terrible name, but it was the best that I could come up with. And it's kind of collaborative infrastructure as code, like plus. And what I mean by that is we start to introduce the concept of a workspaces prefix. So we're trying to look at how we can leverage some of the capabilities within Terraform to have multiple workspaces declared on run, as opposed to having to know what they are before. And so what that means is, you can see within our dev, prod, and staging environments here, we're now looking at leveraging that auto vars capability, so automatic population of Terraform variables. And really the only thing that changes between the environments that we're building here in dev, prod, and staging is that single staging TF vars file. So we can actually have a variable within there for the environment we want to run in, and we're able to set that within a separate pipeline, like a CI/CD pipeline, to drive and configure that, and essentially make Terraform as dry as possible and enable as much reuse within this specific environment as possible. And so we get to a point where we're the driest we can be within our current constraints. We get maximum amount of reuse in terms of what's happening within our specific repository. And we build on all of the goodness that we get out of Terra services. The con with this approach is that currently it has to be done through the CLI-driven workflow. So it can't be used through VCS or a branch-based strategy, right? And there is, again, complexity with the setup, even more so than the collaborative infrastructure as code or Terra service based approach. But what we get with that is, and how that looks, is we start to look at another layer that's within there. And so we have all of the things and benefits we had from having that Terra service approach, and we have this CLI workflow that's in there too. And we start to take advantage of some of the features within Terraform Cloud that sometimes get unused as much, which is working directories, but also the environment variables that are available to us. And so what we can do is look at using the TF workspace environment variable, as well as the workspace select command, to actually execute and change on run which workspace that infrastructure as code gets applied to, which is a really powerful way. It's definitely still growing in maturity, and very few people are at that level where they're looking to get to that next step. But it's something that's pretty interesting that I've seen in a couple of different companies and conversations I've had with some really passionate Terraform users, and trying to look at how do we take it to the next level in terms of reusing modules and capability, and where can we gain benefits from it. So the last thing that I'll kind of touch on is really cool, because I wasn't sure if I wanted to talk about this, but then Tracy Holmes, who is an awesome dev advocate at HashiCorp, put an article up specifically on this, and I couldn't not highlight it and then talk about how good a job she did highlighting the differences that are between the different structure types. So what about repo structures? There's mono repos and multi-repo, right? So it's an age-old debate, which is the best way to go with, which one should we use? Tracy absolutely nailed it, summed it up perfectly, and I couldn't agree more. So there's no right or wrong here. You just need to be aware of the differences in terms of what you're getting into, and maybe the scale at which you're attempting to get to with your infrastructure as code capabilities, right? So within a mono repo structure, we get that single source of truth that we all want, and we get consolidated. We can consolidate an approach to testing and debugging. But as the library of our repository grows, we get a significant increase in overhead as we go further, which leads to a lot more maintenance, therefore cost, right? And we're always trying to reduce that. We get scalability issues for the systems around that repo that are supporting it. We end up having to put a lot more into pipelines or CI/CD tools than we would like because we have to support this structure. We also get a fair few access control issues in terms of, by default, everyone gets read to all of the code within that repo. And maybe we don't want it for specific use cases, or we don't want people to version within that repo. We run into a couple of issues from native features of VCS providers. And then there's my preferred option, which is having multiple repos. And so what that does, it really enables a self-service mentality in terms of how we share the capabilities we've got. Isolated testing, in opposition to consolidated testing, but isolated testing that we can be very specific about what we're testing from a security and a functional point of view. We can version modules or the capabilities in those repos in an isolated way. So we can be very specific through using native capability by using Git tags in GitHub, for example. We get the ability to control access in a lot more fine grain. And my favorite, which is we get to minimize the blast radius of what we're doing. So we're able to really understand where we're making changes and what we're affecting with those changes, potentially, rather than knocking onto multiple projects upstream that we weren't aware we're referencing our module in our repo. The disadvantages of the model is that essentially it takes a bit longer to download the modules that you're using. I reckon that's a pretty good trade-off in terms of what's happening. So the link to Tracy's blog on the HashiCorp blog site is there. 100% give it a read. There's some cool pictures that demonstrate the differences. And again, there's no right or wrong. There's just different. So you just have to make your mind up. Right? I just wanted to say thank you to all the organizers for Hashi Talks. It's awesome. I remember last year was 24 hours. Year before that was 24 hours. And Katie, who organized a lot of it, didn't get any sleep, and now she's able to sleep, which is pretty cool. And we're doing it for 48 hours this year, which is awesome. So awesome, huge shout out to everyone that's involved, the speakers, the people organizing in the back end. It's a huge thing to pull together. And if you want any more information about me, here are some links. Just hit me up and have a chat, and happy to answer any questions there may be. I'll hang around in Google Chat and Twitter and everywhere for a couple of hours answering questions. So yeah, that's me.
Thank you, Lachlan, for sharing with us. I'm asking for questions in the chat. We'll see if we get any live, but appreciate what you brought to the table. Getting a lot of nice presentations back. So a lot of people loved your talk. A couple of Tracy fans too, and excited that you brought up the blog. So all goodness. Yes.
Got to bring up the blog. There's too much good content in there not to bring it up every time.
Right on. So can you tell us a little bit about some things that you've seen kind of in the wild as you've been working on deployments and whatnot?
Yeah, absolutely. I mean, there's some things that scare me that are out there that I that are nervous to talk about, still scarred. I think just realizing how far you can actually go in a really quick amount of time and trying to plan for that in the best way that you can is probably the best advice I've got in terms of stopping those scary moments happening, because there's a lot of people that go, oh, Terraform's awesome. I've just redone my entire infrastructure platform and look how good it is and run. And, I just completely scaled up development to production size and my boss is going to be mad because the bill's crazy. So it's just got to, you just got to be aware of those things that are happening and try to plan for the future, I guess, as opposed to just going at it without thinking about it.
Yeah, that's cool. Be thoughtful in your implementation and work it out. One question, 1%, what percent of Teralith versus Teraless do you see in your day-to-day?
Oh, huge question. So Teralith is still probably, I would say, like 30 to 40%. There's still a lot of people that are getting started, and that's the first thing they do is, I need a TF file, and then I build stuff, and that's how it works. So it's a pretty common thing that people go, oh, why isn't this working? And it's all about that structure. Teraless is like, I mean, super like high end, like it might be like 2% of people have even thought about how to get that level of workspace agility, because it's not really like a supported feature within TFC. You're kind of using a CLI command, which is intended for local, tricking it to think that there's an environment variable that directs it there. So you've got to be careful with that, because it's not something that everyone's doing. But the people that have done it and have done it right, and I've seen it at a big organization running a huge machine learning platform, they got huge amount of reuse about it because every instance was the same. So they had to build it once and they could run it 100 times and they were good to go. But again, you know, a lot of thinking went into that before you hit go. So definitely an interesting question. Hopefully we see more going towards the Terra service side, and then maybe Teraless has a better name and a different feature set later on.
Right on. One more question. I think we've got time. Will the CDK result in more hidden Teraliths?
Oh, huge question. I probably wasn't the biggest CDK fan when it came out, but I don't know. I think any developer writing with anything is going to have a way in which they like to structure and build on things. So I think as long as people are following the right practices for development, we should avoid these days the monolithic based approach to any kind of application or infrastructure, be it with a Terraform CDK or be it with a Java application in Spring Boot, wherever it is, right? So I think as long as people are trying to reduce blast radius and make things controllable, we'll see less of them, but it's always good to be aware of it and you know, try to push the right way. Peter, I think you asked the question.
Yes, it was Peter. So thanks again, Lachlan. Sorry again for the green room mix up. I actually went and fired those guys. Don't worry about it. So,
okay.
So no more boundary on top of your Terraform talk. So
next year.
It's going to be great. So thanks again. And we look forward to seeing more of you in the future.